Hey there, and welcome to our lesson video for rationalizing with radicals. Now, rationalizing, that's a big word, but what that means, what our learning target is to get rid of radicals in the denominator of a fraction. You're never allowed to have any kind of root house at the bottom of your fraction, so we're going to figure out in this lesson how to get rid of them. So, I have this example here, and you notice that I have a big fraction under this square root house. I've got 3/5. And notice how in my first step I broke it up. Square root of 3 on top, square root of 5 on the bottom. Now, like I said, the problem, you're not allowed to have square root in the bottom of the fraction. So that's square root of 5. How can I get rid of it? Well, here's how I think about it. I realize that my root is a 2, so I need a pair of something. But underneath the radical house, I only have 1 5. So what do I need to make myself a pair? I need 1 more 5. So you see how I have times this bar here, a special fraction is what I call it. And in that special fraction, I'm going to put whatever I need on the top and bottom. Make sure it's the same. So like I said, I need a 5, so I'm going to put square root of 5 both on top and bottom. And now technically, I have a pair of 5s at the bottom of my fraction. So I can, because I have a set, that means I can take a 5 out, and you notice how there's nothing left between my two denominators, so I got rid of my square root house. So that's how you get rid of those radicals that are at the bottom. Now at the top, we're just going to multiply across the top. Since they are both square root houses, I am allowed to multiply the numbers underneath them and make it simply the square root of 15. So, see, I just got rid of my square root of 5 that was on the bottom, and it really wasn't that bad. So, let's look at this one, our second example. Again, I've got one big square root house, so I'm just going to break them up. Square root of 5 on top, square root of 6 on the bottom. Now, again, it's a square root house, so I'm looking for pairs. I need 2 things to circle to have a set. Now, 6, I can break that down. So let's see what we've got underneath on the bottom. I've got a 2 and a 3. So if I'm thinking about pairs, what do I need? Well, I would need another 2 and I would need another 3 to have a pair. So in this special fraction, we're going to put exactly what I need, both on top and bottom. So technically, I can say, looking at my denominators, okay, between them both, I have a pair of 2s, and I also have a pair of 3s. So I'm going to take a 2 and a 3 out on the bottom, and there's nothing left between my two bottoms of my fractions. So my square root house, again, went away, which is our goal, getting rid of them. And again, since they're both square roots on the top, I can just make that the square root of 5 times 2 times 3. But all this multiplication, I should clean it up. So let's see, on the top, 5 times 2 times 3, that would just be square root of 30. And on the bottom, that would just turn into a 6. So this would be my equivalent form for example 2, but just proper, where I don't have the square root at the bottom. Okay? So let's keep kicking it up a notch. This time I've got a cube root house at the bottom, and I'm supposed to get rid of that. So let me factor tree what's under there, that 9, and notice that I have 2 3s. But based on this number, I need 3 of them. So I don't have enough. So what I'm going to do, let's just turn this into a times here, and I'll write my equal a little bit farther down. I'm going to need another 3 to have a set of triplets there. So the top and bottom, I'm going to rewrite a cube root house, but I'm going to put a 3 under both of them because that's what I need to have a set of triplets. So between my two fractions, on the bottoms, I have triplets. So that means a 3 can come out. Now there's nothing else left between my two fractions on the bottom. So my cube root house went away, which was my target, and I just have a 3 down there. Now, on the top, I have a 4 that's outside, and I have a 3 that's under a house. Because one's out and one's in, I cannot multiply them to get 12. Rather, I just kind of rewrite it. 4 stays outside, and then I still have the cube root of 3. Now you should always double check. Think of this as a fraction, 4/3. Will that reduce? And if it does, you should reduce it, but lucky for us, it does not. So I can say that that would be my rationalized answer. Okay. Let me skip ahead to where we've got some letters, because I want to make sure I fit all my examples in for you. So I'm going to skip ahead to this example 5, and I'm going to break it up to where I've got the cube root on the top, and I've got the cube root on the bottom. Okay, now it looks like I'm going to have to simplify both the top and bottom, but let's get this bottom figured out first. And you know what? Let me change something here. Okay, I decided I'm going to change this. So let's get rid of that 7 and just make it a 2 up there, because I don't think we're quite ready to make that big of a jump. So this is going to make it a little easier for us. So I didn't change the bottom at all. So I'm going to factor tree that. So I'd have a 3 and a 3, and I have 2 y's. Now, based on my index here, I need triplets, but I only have pairs of everything, so I'm short. So whatever I need, remember, we're going to use this special fraction. So I'm going to write a cube root house. Whatever root house is in your original problem, make sure that's what you use in the special fraction. And how many more 3's do I need to have triplets? I need 1 more 3. How many more y's do I need? I need 1 more y. So just make sure you copy that to the top so that both top and bottom are the same. Okay, so now let me compare. Between my denominators, I have triplets of 3's, so I'm going to circle this set of 3's. And then I also have triplets of y's. I've got 3 y's. So I've got a set of 3's and a set of y's. So what's going to come out? A 3 and a y. Now between my bottoms, I don't have anything left. I've used everything between the 2 fractions. So I got rid of my cube root house, which is what I wanted to do. Now looking at the top, they're both cube root houses, which is super nice, because then I can just multiply everything under there together. So I'm going to multiply the 2 with the first fraction with the 3 from the second one. And then I'm just going to rewrite the x cubed and the y. So let me clean this up. Let's see what we're looking at. We're looking at 6x cubed y over 3y. Okay, so technically everything we've done is right, but as far as being done, I just want to warn you, sometimes, especially like on an ACT test or a college test, they're going to do this, where you did all this work to get rid of the radical on the bottom. But take a look. If you think about factor treeing the top, you know, you've got 2 and 3, you've got 3 x's, but you just have a single y. Technically, do you have triplets on the top? And by golly, look at this. We do. So you've got to watch. Sometimes, I don't like to do it so much because you've gone through so much work getting the bottom correct. But just to forewarn you, this might happen, like I said, on an ACT. You might have to go back and then simplify the top. So that would mean an x would come out, but that's the only thing that we had a set of 3 of. So everything else, the 2, the 3, the y, would go back under. So 2 times 3 is 6. We just had the single y, and we have 3y on the bottom. Okay, so I wanted to make sure I showed you an example, just in case that might happen to you on some college test. Okay, but I will try to steer clear of that. Let's do this guy. Okay, so looks like I've got a big square root house, so let me break it up. Square root of 2x on top, square root of 3y cubed on the bottom. Because it's a square root house, remember we've got little 2's here, so we're looking for pairs. So when I start factor treeing, I just have a 3, however I have 3 y's. So I need pairs, so I do at least have a pair of y's, but I still have some stuff that's left over. So that's not good, because that means I still have a square root at the bottom, because you know the 3 and the y would go back in. So I need everything to pair up. So I'm going to need this special fraction, and I need the 3's to pair up. So how many more 3's do I need? I just need one more 3. And this leftover y, I need him to pair up too, so I need another y for him to have a pair. So put this on the top and bottom. And so now technically between the two fractions I can say I have a pair of 3's on the bottom, I have one pair of y's, and then I have another pair of y's. So now everything is used up at the bottom of my two fractions. So from each set, a 3 comes out, and then I have a y and another y. So I have 2 y's, so y squared. So on the top, again, they're both square root houses, which is wonderful, so I can just multiply what's under there together. So 2 times a 3 times an x times a y. And so I'm just going to clean that up. 6xy, if I multiply 2 times 3, and then 3y squared. Awesome! My square root is gone from the bottom, and I am ready to rock and roll. All right, I think we're doing pretty good on time. Let's see. Let's do this example 7. Okay, I've got a 4th root that I'm going to break up. 8x cubed, 4th root is 16y squared. So my goal is to get rid of that 4th root on the bottom. I've got to do it. It cannot be there. So let me factor tree the 16. 2, 8, 2, 4, 2, 2. Woo! I had just enough 2's because I need 4 of them based on the index. Okay. But how many y's do I have? Dag nabbit, I only have 2 y's. Okay, so I'm going to have to do this special fraction because these guys would go back in the 4th root house, and that'd be a mess. I'd still have one at the bottom, a 4th root house at the bottom. So let me make a special fraction, both with a 4th root on top and bottom. How many more y's do I need? I need 2 more. Okay, so I already have a set of 2's, which is good. And now technically between my two fractions, I can now say I have a set of y's. So what's that going to do for me? That's going to mean at the bottom, a 2 will come out and a y. Okay, now everything is used up on the bottoms and my 4th root house went away. And then on the tops, they're both 4th root houses. So we're just going to multiply all this together. 8x cubed. I had a y times a y, so I'm just going to write that as y squared. And if you think about the top, if you do a factor tree, you would not have 4 of anything. So like that one example I showed you, we are actually golden on this one. All right, I think I can squeeze in one more with my time limit that I've got. So let's do this. Split up my cube root, top and bottom, to z squared x, to the 5th. Okay, so I've got a single 2. I need triplets, by the way. Okay, I've got a single 2. I've got 2 z's, and I've got 5 x's. Okay, so if I do a special fraction, didn't mean to put that equal there, I need cube root house. I need 2 more 2's to have triplets. I need 1 more z. I already have triplets of x's, but I have 2 left over. So those guys need to make a triplet too. So I need 1 more x to have a triplet of x's. So notice I've got the same thing on top and bottom. Okay, so I'm going to have a 2 that comes out on the bottom, a z that comes out, and I'm going to have 2 x's that come out on the top. Sorry guys, I know I'm rushing, but I'm about to run out of time. I'm going to multiply everything 4, and I'm going to write it in alphabetical order. X, Y, 4, Z. However, you've got those 4 Z's, 4 Y's, that we're going to have to take a set out. But you know what? I'm going to run out of time. We will finish this up if you have questions. Why don't you finish this as a preview problem? And then also, here are the two that I will definitely check before class. So have fun and keep learning.